9, 8, 7, 6, 5, 4, 3, 2, 1, fire.
We have ignition of NASA's Space Launch System 5-segment solid rocket booster.
The historic Artemis 1 mission was successfully launched from the Kennedy Space Center in Florida on 16 November 2022. Its main objective is to test and send the unmanned Orion spacecraft around the moon and re-establish human presence on the moon and pursue scientific studies. The primary operations goal of the mission is to assure a safe crew module entry, descent, splashdown, and recovery. Let's see how feasible these goals are and the science behind them. The Orion crew module is a reusable transportation capsule that provides a safe habitat for the crew. The crew module is capable of transporting 4 to 6 crew members beyond the moon, providing a safe habitat from launch through landing and recovery. Inside the deep space capsule are advances in life support, avionics, power systems, and advanced manufacturing techniques. Orion CM will use advanced technologies, including glass cockpits, an auto-deck feature, improved waste management facilities, and a nitrogen-oxygen mixed atmosphere. The second goal is descent, to me, which is escape speed. That is the speed the orbiter must achieve to break away from the gravity of the moon. The gravitational attraction between any two objects is therefore given by one of the most famous equations of all science, which is F gravity equals G multiplied by the masses m1, m2 divided by r squared, where F gravity is the gravitational force between the orbiter and the moon, m1 and m2 are the masses of the two objects, and r is their separation. G is a constant number known as the universal gravitational constant, and the equation itself symbolically summarizes Newton's universal law of gravitation. If we wish to orbit a planet, we must slow the spacecraft with a rocket when the spacecraft is near its destination, allowing it to be captured into an elliptical orbit. Additional rocket thrust is required to bring a vehicle down from orbit for a landing on the surface. A rocket's acceleration depends on 3 major factors. Firstly, the greater the exhaust velocity of the gases relative to the rocket, the greater the acceleration is. The second factor is the rate at which the mass is ejected from the rocket. The faster the rocket burns fuel, the greater its thrust, and the greater its acceleration. The third factor is the mass of the rocket. The smaller the mass is, the greater the acceleration. NASA's Space Launch System (SLS) is the most powerful rocket to fly. The third goal of the mission is splashdown. After an estimated mission length of 26 to 42 days, the module will splash down in the Pacific Ocean. Finally, recovery. A space shuttle has a number of reusable parts. Solid fuel or rocket boosters on either side can be recovered and refueled after each flight, and the entire orbiter can be used for subsequent flights.